So, what do you do when you lose your microphone holder in a pandemic, and you definitely don't want to go out to buy one? And it's a non-essential item. So, if you were to order one from Amazon, it'll arrive sometime in mid-July. Well, you design one yourself. So the design of a microphone holder itself isn't too complicated. There's a thready part at the bottom that screws onto the top of your mic stand. There's a grippy part at the top that holds your microphone. And then there's a bendy part in the middle so you can adjust the angle of the microphone. However, working with threads can be a bit tricky, and the threads on this microphone stand are very small. It's a 5/8 inch, 27 teeth per inch thread. That's pretty tiny. So working with threads in general can be difficult, and working with threads that fine can be even more so. So we're going to spend some time looking at threads. And then the second part is the bendy part. Two pieces of plastic slide against each other unless you really have some pressure holding them together. So we're going to put some teeth on kind of the middle part where the two pieces of plastic would meet to adjust the angle of the microphone. And we'll use some fusion tricks to make that happen. So the first thing I'm going to do here is I'm going to create kind of the tube part that's going to screw onto the top of the mic stand. Now I know that it's a 5/8 inch thread, so even though my design is in millimeters, I can still type in 5/8 inch and it'll do that conversion for me. So it's just about 16 millimeters. Now I know that I want to have about a 3 millimeter wall around the threads, so I'm going to add 6 millimeters and add a 22 millimeter diameter circle around that 16 millimeter circle. So adding threads to a surface is pretty easy. You just pick the surface that you want to be threaded, you go up to create and pick threads. So in this thread dialog, you're going to see a big list of thread types, and unless you're in the thread business, you may not know exactly which thread type your threads are going to fall under. So it could be kind of a guess and check situation for it. But I found my 5/8 27 thread in the ANSI unified screw threads. 0.625 is 5/8, so I might have to do a little math there as well. And then 5/8, we're at 5/8 11. I need a 5/8 27. So this is the right thread for my microphone stand. But as you can see, what it's trying to put onto the shape itself is just painting. It's just drawing threads on there. So in order to turn these kind of fake painted threads into actual modeled threads, you check this modeled box, and now they are a 3D object that we can manipulate. If I was making this out of metal or something more substantial than 3D printed plastic, these would probably be tap threads. It's, you're probably not going to press something this fine or to mold something this fine. You're probably going to tap it out. So you hit OK, then now effectively you have made threads. In a perfect world where everything has perfect dimensions, and 3D printers don't have any slop or any press or any wander, then this would be exactly what you wanted. But we don't live in a perfect world, and as 3D printer filament is extruded, things happen to it. So we have to add in a little slop factor. So on fine threads like these, what I'm going to do is I'm going to select the inner face, and that's inner I-N-N-E-R face, and that's going to affect the thread depth. So I'm going to push that back using press pull, 0.15 millimeters. Alright, so now shouldn't have a problem with the threads being too deep on the nut side. Now you can also select the upper and lower faces. So this is kind of the bottom side of the thread, and it spirals all the way up through the threads. You can theoretically pick the top as well, and that would spiral through the whole thing. You don't have to change both. If you change either one of them, that's going to give you more vertical gap in your thread. So I'm going to do the same here. I'm going to press and pull that by 15/100ths of a millimeter. So that little bit of adjustment should give me enough gap to screw the threads on easily without eliminating all structural integrity of the threads themselves. Alright, so now I'm going to kind of speed through this a little bit and not narrate the whole thing, because most of this work, until we get to the teeth part, most of this work is just, you know, drawing and pressing and pulling. So I'll speed through it and get to the interesting part. Now I'm going to make the teeth. This is kind of the other interesting part of this design. I would like to put teeth on both sides of these cylinders so that when I tighten down the screw, the teeth kind of lock it into place. I'm going to do that by creating a new sketch on the cylinder. I don't want the teeth to go all the way to the outside, so I'm going to sketch this out to 29 millimeters. Then I'm going to draw this vertical line. And I'm going to bring it out 1 millimeter to each side. And then we'll pull those back down to the center. And that's going to be the shape of our teeth. So I'm going to grab those, extract them out by, let's say, 1/2 millimeter. The teeth don't need a whole lot, they're just there for texture. I think that looks pretty good. I'm going to fillet the edges and see how much material it takes away, because as you fillet the top, it's going to start eliminating kind of the bottom down here. And that is going to be just about perfect. Okay. So I did make a mistake. I did extrude a join for that tooth, so now it's all one body. That's going to make things more difficult whenever I try to replicate these things both around the cylinder as well as on the other cylinder. So I'm going to go back to that extrusion and create a new body. There. So now we have a new tooth. So now I need to replicate this tooth. I need this to be repeated all the way around the cylinder. So to do that, I'm going to construct a axis through a cylinder, and I'm going to pick our inner cylinder here. So now I have an axis going through the exact center of the circle. Then if I go to create pattern circular, I can pick the object. I want it to be a body. I can pick the body that I want to replicate. I pick that axis I just created, and then I tell it how many times I want to replicate. So the key here is that I want the distance between the teeth to be just under the actual width of the tooth, and I'm just I'm going to kind of eyeball it. You know, I can overestimate and not. You know, I can overestimate the number of teeth. You know, reducing this gap size, and it won't do much. You know, the teeth will still fall between each other. If I underestimate, that's when the teeth could theoretically shift, because you know they will be sitting on flat surface instead of pressing against each other. So that definitely looks like I have less gap between the teeth than the width of the teeth. So 25 teeth looks like it will do just fine. And there they all are. There's a bunch of them. Whole 25 bodies, brand new bodies out there for our teeth. But I think that looks really good for what we're trying to accomplish on that surface. Now what I'm going to do is I'm going to take those 25 teeth, and I need to replicate them. I need to put them on the cylinder that's on the other side. This one that we hid, that's going to be the top section. I need the same teeth over here. So I'm going to create a copy as I move. Now I need to flip them around, and my axis is kind of oddly on one of the teeth. So I'm going to set the pivot point, and I can set it on this axis that I created through the circle. I know that that's going to be the exact center. I can then grab our new teeth and rotate them around 180 degrees. And if I bring back that body, they look like they are now pressing against that body. And in fact, they went ahead and, oh no, they didn't. Oh no, I just have a ton of teeth down here. Look at all those bodies, man. All right, so I'm going to hide that guy for now. I want to select all of the left side teeth. And I know it's going to be 25 minus 3, I guess plus 3, so 28. Is that all of them? Should be all of them. Yeah, that looks right. And I'm going to merge them with... No, oh man, all right, so hold on. You, through 28. There. So I'm going to merge these all together. This is all going to be one body. And then I'm going to hide that guy. I'm going to do the same on the other side, so everything you can see here. And it looks like while it looks like those bodies are touching, they aren't actually touching, so therefore this guy failed. So I'm going to pull him back. And we're going to select all of these guys again. And we just need to move them a fraction of a millimeter. There. In fact, that's even going to be too far, but it doesn't matter. They're just teeth. They'll be fine. There. Now we can merge all these guys together. And as you can see, as those two tighten, those teeth will fall in between each other and lock this little guy into place. So that should be just about perfect. All right. So now that the teeth are done, again, we're back to kind of basic sketching and extrusion. So I'm going to speed it up again, and we'll take a look at the finished product. So here we have the finished mic holder. We have threads that should thread on to the end of the mic stand. We have teeth that should keep the mic adjustment from just spinning out of control. All that's left to do is 3D print and try it out. So here we are in Kira. We're going to import both of our mic stand pieces. This bottom piece has a logical printing orientation because it does have a nice big flat surface. So we're going to lay that surface on the plate. The top, not so simple. Our best bet is going to be to print on one of these two faces. They are rounded, so that's even not going to be that great, but they're not as rounded as, say, like the bottom of this of the cylinder. So I'm going to go with the top face first. If I print the top face first, or sorry, the top face down, pick you, lay flat on. If I print with the larger face on the build plate, what that means is that as it's building, layer by layer, the inside layers are going to be the ones that overhang. So there's more likely to be some kind of goofiness or error or something that doesn't look right on the inside versus the outside. The outside's going to look better than the inside. Now, the other thing you're going to be concerned about when you're slicing these guys is that A lot of Slicer's crew included likes to put supports right way up, against the walls, basically. Now, these threads have a depth to them, so if you are putting supports a millimeter from all the walls, then you're going to be basically touching a lot of the threads with your support. So you probably want to back those away a bit. And I've already got this guy set up. I believe I pulled him back to like 2 millimeters. Yeah, this support XY distance 1.5 millimeters. So now when I slice this, you will see that there's plenty of gap between the edge of the supports and where the threads start. So it's going to make it a lot easier to remove this stuff. I've printed mini thread tests before, and without that necessary gap, you may end up with filament pushing into your threads, and it's a chore, man. You're better off just reprinting the things a lot of time. So here's the part pretty much straight off the printer. We'll have some support cleanup to do, but the support in the threads, with just a screwdriver, they pop right out. So our threads screw on to the mic stand without much of an issue. They'll be a little tight the first time as the plastic's kind of conforming to the thread a bit. But they're definitely not weak. They're definitely just about right for holding a microphone stand. So the easiest way I found to install a nut into a nut capture is to first put the bolt through the hole, put the nut on the bolt, and then pull it into the capture. Now this capture was a little bit large. In the final version, I'm probably going to reduce it by 1 millimeter or so. I kind of like the nut to pop in and be held firmly in place by that nut capture, and this one's a little loose. So now we can affix the top and bottom pieces to each other with the GoPro bolt. If you leave it a little bit loose, then you can move the mic holder pretty freely. If you tighten it back down, it's not going anywhere. And now we can insert the microphone into the holder. It seems to grip pretty well. Give it a shake, and it's not going anywhere.